Hey guys, welcome back to another exciting challenge. Today we are tackling problem 9 to 16, which make up part B of the 2019 Math Kangaroo competition for grade 3 and 4. We'll go step by step, breaking down each problem with smart strategies to help you solve them faster. Think fast, stay sharp, and let's ace this together. Ready? Let's jump in. Problem 9. Linda pinned up 3 photos in a row on a cork board using 8 pins. Peter wants to pin up 7 photos in the same way. How many pins will he need it? These are our options. Linda pinned 3 photos using 8 pins. For 3 photos, she used 6 pins for the photos and 2 extra pins for the space between them. So we see that for the 3, she do 8. That means she did for 3 pictures, she did 2 plus 6. Do you agree? This is an extra one. So for 1 card, 2, 2, 2, 3 and then extra. For 4 cards, she would do 2 plus 2 more. That is 8. For 5, she would do 2 plus 10. For 6, she would do 2 plus 12. And for 7 cards, she would do 2 plus 14. That means 14 plus 2 gives 16. And our answer is option B. So she would need 16 pins to carry on 7 cards. Perfect. Let's solve another problem. Problem 10. Edgar builds a cube of small cubes. He already arranged several of them as shown in the figure. What is the smallest number of such cubes he should add in order to finish the work? These are our options. Edgar has already used 8 cubes to start building his larger cube. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. So he has already done 8 cubes he has already used. Now he is working on 3 by 3 by 3 cubes. So you say 1, 2, 3 here, 1, 2, 3 and height is 1, 2, 3. So volume of 3 by 3 by 3 cube would be 3 into 3 into 3 gives us 27. So he might need a total 27 cubes. He has already used 8. So 27 minus 8 gives us 19 cubes. So Edgar needs 19 more cubes to complete his 3 by 3 by 3 cube. And our answer is option C. Problem 11. Suppose you have exactly 25 square tiles. Use them without cutting to tile to 2 square areas with no tiles left over. If you compare this to square areas, how many more tiles were needed for the larger area compared to the smaller area? You have 25 square tiles and need to use them to tile 2 square areas. So one is the smaller and another is the largest tile area. Our goal is to determine how many more tiles are needed for the larger square compared to the smaller square. So we have to distribute this 25 square tile. Let's try to figure out the sizes of the squares. So for example, let's say 2 by 2 square, we would need 4 tiles. For 3 by 3, we need 9 tiles. For 4 by 4 area to cover, we need 16. Now you see that 9 plus 16 gives us 25 tiles. So can we say that we have 3 by 3 small square tile and 4 by 4 is the 16 is the largest. Now the difference between 16 minus 9 gives us 7, and that is the difference between a larger area to a smaller area. So our answer is option C, 7. Problem 12. Six stripes are woven into a pattern as shown. What does the pattern look like from the back? This is the pattern we have and it's being woven. We need to find it out what the back of the pattern looks like. So for this kind of problem, what I usually do is I focus on one of the visual and I see what I expect. So I focus on the center one, for example. So I see there should be a 2 yellow going behind this. So what I would see on the behind, I will see 2 yellow and 1 cyan color. So we go in here, option A, this is not possible because we see 3. We see 1 here, not possible. We see 2 and a cyan, that could be our answer. Let's move on. We see 1, not answer. E, 1, not an answer. So our answer is option C, is the back of this woven pattern. Perfect. Let's move on to another next challenging problem. Problem 13. A full glass of water weighs 400 grams. An empty glass weighs 100 grams. How many grams does a half full glass of water weighs? These are our options. We know that a full glass of water weighs 400 grams and empty would bring 100. Now we have to find the weight of this glass. Easy. To find the weight of just the water, what we would do? We would take out 400 minus 100. Gives us 300. So just the water weighs 300 grams. Now we know that it is half of 300 grams. So what is half of 300 grams? Divide by 2. Gives us 150 grams. Now 150 gram is the weight of the water, but we also need the weight of the jar. So what is the weight of the jar? That is 100 grams. So 150 plus 100 gives us 250 grams. And 250 gram is our answer, option D. Problem 14. The weight of a dog statue is a whole number. One dog statue weighs less than 12 kg. How much could one dog statue weigh? These are our options. And this is what it means with the picture. We have a dog which is less than 12 kg. 2 dogs is more than 20 kg. So let's find it out with this clue. So we have one dog statue which is 1 to 4 to 11 kg. So this dog here sees that it's 11 kg. If it is 12, then it's equal. So this is not right. So we make it is less than 12, that is till 11 kg, and any number of this. We don't know. That is what we will find it out. Another clue says 2 dog statues are greater than 20 kg. So if we divide these dogs 20 kg into 10 and 10, that means the weight of one dog, that is 10 kg, plus 10 kg, that is more than 20 kgs. So now we know our weight lies between 10 kg to 12 kg. So what could it be? If we increase by 1, we say 11 plus 11, we give it 22 kg. That means it's way more than 20 kg. So this is what we got. Now here we see we have a dog which is 11 kg. That is 11 is less than 12 kg here. So this is our answer, 11 kg, which is option E, 11 kg. Problem 15. Stephen wants to write each of the digits 2, 0, 1 and 9 in one of the boxes of the addition. These are our boxes. He wants to get the largest possible result. Which digit could be written instead of the question mark? And these are our options. The goal is to find which digit would go in ones places of the second digit to get the largest possible results. To maximize the sum, we want the largest digit in the higher places, tens places. So what we could do, we could write 9 here. So we cancel 9. Now the next highest digit is 2. So we write it in 2 in here. Now we can replace 0 and 1 here. And see, we get the maximum digit sum here. And that is 111. So we get 1, 9 plus 2, 11, and we get 111. This is one possibility. Let's do another one. If we write maximum digit 9 and 2 here, and we say 1 and 0, we will again get 111 as our sum. So we could either place 1 or 0 in this block. So our answer is option A, either 1 or 0. Problem 16. We have 3 fruits here. Together we cost 5 cents, together we cost 7 cents, together we cost 10 cents, and we need to find out how much do we cost together. So as I was mentioning, we have 3 fruits in here, an apple, peach, and a banana. Now what does this mean to us? We say together we cost 5 cents, means apple plus peach cost us 5 cents. Banana and apple cost us 7 cents. Peach and banana cost us 10 cents. So now we know that apple, banana, peach, we all add together and we have to find out all them together. So we add these 3. Since we add this side of the equation, we add 2, 5 plus 7 plus 10 gives us 2 apple, 2 peach, 2 banana, and 22 cents. We divide by 2 on both the sides of the equation. We get 1 apple, 1 peach, 1 banana, and 11 cents. So all this together would cost us 11 cents. And our answer is option D, 11. Perfect. That wraps up part B of the 9 to 16 question from the 2019 Math Kangaroo for grade 3 and 4. Make sure to like, subscribe, and hit that bell so you never miss a new challenge. See you in the next problem solving adventure. Stay tuned for part C of the 2019 Math Kangaroo for grade 3 and 4.